Hello everyone. Today let's look at this simple problem where we consider an object which is under the influence of a pushing force, friction force, and we have to find an acceleration. So let's read the problem together. A man is pushing a 10-kilogram box with an 80 Newton force as shown in the figure. If the coefficient of kinetic friction between the box and the surface is 0.5, find the net force on the box and the acceleration of the block. In order to solve this problem, let's consider a free body diagram. So 80 Newton force is pushing, friction force is in the direction opposing to the direction of the motion. Object has a weight of mg and then a surface acting on this object with a normal force. So that's how the free body diagram looks like. Let's consider object in two directions, x and y. So let's start with y direction. Since object is not moving up or down in y direction, normal force has to be equal to the weight of the box because they're balanced. So normal force to this applied by the surface on the box is going to be just mg, which is 10 kilograms times the gravitational acceleration, which is 10 meters per second square, gives us 100 newtons. Now, in x directions, forces are not balanced, so there is going to be a net force because object is moving. Right? First, let's calculate the friction force. Friction force is going to be equal to coefficient of friction times a normal force. If we work this one out, we get 50 newtons. So now the net force is going to be pushing force minus friction force. So the net force is essentially 80 newtons minus 50 newtons, which is 30 newtons. So this answers the part A of this equation. So the net force on the box is 30 newtons. Now let's find the acceleration of the box. Well, we know that from the Newton's second law that net force is equals to mass times acceleration, or acceleration is simply the force we just found divided by mass of the box, which gives us 3 meters per second square. And that's the answer. Thank you.